And you can see the screen, right? Okay. One second. Okay. I'll start the session for today. All right. One second. I need to check something. Yeah. So good evening and welcome to today's session. It's on circular economy. So last week we had a session on municipal solid waste management. This is an extension of that, okay? Because municipal solid waste management is kind of it's a measure for circular economy. What is circular economy? All that I'll just be explaining. Let's go over the contents for today. So, so first, as usual, we'll discuss the answers to the questions from last week, and then we'll go into the circular economy, the introduction, broad definition, evolution, and depth of the idea. So, what is circular economy? We'll just be covering, and the R's of sustainability like reuse, recycle, remanufacture, and so on. I'll just tell you what those are. Then systems thinking perspective, and then a couple of case studies. One is medical waste management case study, and the other is waste to energy case study. So the second case study is not exactly on circular economy, but it can be classified as such in circular economy. I'll tell you how I've also explained it in the slide. Okay, and then we'll go to the questions for this week. So from last week we had the first question was the term municipal solid waste denotes. So what is municipal solid waste? So it is the solid waste resulting from community, city, commercial, institution and recreational activities. So they can include recyclable materials, compostable, that is biodegradable material, inert material like stones, some rocks or some kind of materials that do not react or do not cause any harm, and hazardous waste which cause a lot of harm like medical waste. Okay, they are classified as hazardous waste. So the right answer is solid waste produced from cities or communities. The second question was which among the following are compostable waste? So what are compostable waste? So compostables are biodegradable waste. So what is compost? Compost is nothing but organic manure. Okay, so if you take any organic waste, right, so your kitchen waste or garden waste and so on, and then you just put it in you put it in some favorable condition for bacteria to act on it, microorganisms to act on it. Okay, you need some favorable temperatures and all that. Okay, once you do that, the bacteria will decompose this organic matter, and what will remain is the organic manure which is called compost. Okay, so they can either be converted into manure or to biofuels like biogas or bioethanol, which you have seen like through fermentation. Okay, so in this case used injections come under hazardous or toxic waste. Waste paper is recyclable, so it's not organic waste, it's recyclable waste, although sometimes you may say that it is biodegradable, but you cannot club it with your kitchen waste. Okay, so it has to be separately recycled and then used again. Okay, stones are inert waste because stones are not going to harm anyone or it's not going to react with anything else. Okay, but banana peel is a kitchen waste, right? It's an organic waste, so and it is compostable. Okay, so that is the answer. So number 3, which of the following statements are true? So unsanitary landfills and open dumping grounds are dump sites that include a combination of all types of waste. So there are biodegradable, non-biodegradable, inerts, hazardous waste, everything together. You dump it together. So that forms unsanitary landfills and open dumping grounds, right? So open dumping grounds are basically unauthorized. You can call them unauthorized dumping grounds or unauthorized landfills, because in any city, if you see, at least especially in India, you go to some places, the people are using these places as dumping grounds. You would have seen it in many places, all right, but it's not officially allocated by the government. But landfills are something that is officially allocated by the government, and the government itself dumps all the waste in these landfills. Okay. So because of these unsanitary landfills and open dumping grounds, methane, carbon dioxide, and ammonia are produced because of anaerobic digestion. Okay. And if you're not using proper personal protective equipment, okay, like gloves and masks and some hazmat suits and all, okay, it will cause health and respiratory problems. So the answer is all of the above. So all of these statements are true. So again, identify the true statements. Okay, so if we take this statement, secondary segregation is better than primary segregation in terms of cost and resource efficiency, that is false, because primary segregation, so what is primary segregation? It is domestic segregation at the source. So in your house only you are separating your biodegradable and non-biodegradable and sanitary waste. Okay, that is hazardous waste. So once you do that, the city does not have to spend extra money for or extra manpower to segregate the waste. Okay, and or sometimes they may use some machinery which will require some more energy, which will cause energy expenditure, right? So primary segregation is always better than secondary segregation. Okay. Then if you look at the other statements, waste such as paper and plastics are compostable. It is not compostable. We just saw it. Waste, paper and plastics are recyclable. And landfills, unsegregated wastes in landfills, they cause a lot of health issues and global warming and pollution. So they are not sustainable at all. So the answer is waste segregation at source is called primary segregation. All right. The next question was about refuse derived fuel. So refuse derived fuel is a combustible part of the municipal solid waste. So you take the municipal solid waste, you have your recyclable part like your paper, plastics and all that. But those can be combusted also. So you can burn them. Okay. But if you burn them directly without energy recovery, that is going to cause pollution. So instead you take them apart and then you convert them into pellets or some usable form, right? And then you use it and to produce electricity or some biofuels or something. Okay. So that is refuse derived fuel. Okay. So so this is this refuse derived fuel can be converted into energy only, or energy recovery can happen only through thermochemical means. So the others like hydrolysis and fermentation, that is biochemical, anaerobic digestion is also biochemical, and transesterification is a chemical process. Okay, this is used to convert bio oil to biodiesel. So incineration, which is just combustion essentially, so that is used to recover energy from refuse derived fuel. So which among the following are sound MSW management practices? So we discussed this in the last week, right? So landfill gas recovery, so you have landfills, right? You already have unsegregated waste there, and the gas that is produced there because of anaerobic digestion consists of methane, carbon dioxide and ammonia and so on. So once you recover that, you can use that methane in some other process, like let's say to produce heat or to produce electricity or something. Okay, so that is a good practice, but not as good as the other two, which are in situ composting of organic waste, which means that you're doing primary segregation, and then you're using the wet waste, that is the biodegradable waste, and producing compost in your own house or in your own apartment complex, like they're doing in my apartment. They're doing the same thing. Okay, and uh, the next one is extracting and converting combustible recyclables into RDF, that is refuse derived fuel. So that is also a very good practice. Like I said, this is a cure to the disease. The disease is the management of municipal solid waste. So we have to reduce the waste as much as possible, right? So this is a cure. Okay, these two are preventions. So all of them are sound management practices, however. So what is meant by collection efficiency? So first, you have the municipal solid waste produced. You have certain amount of MSW produced from a town or a city or a community. Okay, how much of it is recoverable from these sources? Okay, so the city employs a lot of people for garbage collection. So how much of this garbage is collected? So that is the collection efficiency. Okay, so the answer is the percentage of overall MSW collected through proper channels for further processing. Okay, so this is important, through proper channels. That means that if you go and dump your waste somewhere, okay, in some open grounds or something, that is not proper collection, right? Or that is not, technically you have disposed of your waste from your home, okay, but it's not collected by the proper authorities for further processing. All right, so that's very important, the collection through proper channels. And the eighth one was, why is burning of municipal solid waste without energy recovery a bad management practice? Okay, so when you burn the MSW, it could lead to emissions of carbon dioxide, carbon monoxide, NOx, sulfur dioxide, and particulate matter. Okay, so carbon dioxide here, it causes global warming. The others cause air pollution, like carbon monoxide, NOx, and particulate matter, PM 2.5. Okay, and SO2 causes acidification. So SO2 is produced if there is sulfur in the municipal solid waste. Okay, if there is no sulfur, then SO2 will not be produced. Okay, so SO2 causes acidification. So the answer is global warming, air pollution, and acidification. So both A and B. So do we have any doubts in these questions? So because today's lecture is connected in some way to the previous lecture, so I hope you understood everything from the last week. If there are no doubts, I can just proceed with today's lecture. Okay. All right, I'll just proceed. Okay, so circular economy. So first, let's talk about economy. So what is an economy? So economy is a system concerned with the production, distribution, trade, and consumption of goods and services by different agents. Okay, so you're producing something. So there is an industry, let's say it's producing something, and then it is selling to some wholesalers, and then from wholesalers it goes to retailers, and then from the retailers you are purchasing that product, right? Okay, so this entire chain, so that also comes under the economy. Okay, so the agents can include, like I just said, individuals, businesses, organizations, or governments. And here I just gave you the example of wholesalers, retailers. So these are businesses, or these could be individuals, right? Then the production of goods includes right from extraction of raw materials, conversion into final product, distribution and supply, okay, to reach the end customer. So it is very important to note that it also includes extraction of raw materials. So from the earth, right, if you want some metals or something, so you need to mine for the metal ores, okay. So right from there you need to consider, okay, the entire supply chain. So if you see, all the energy, resource and nutrient cycles allow the resources to return to the environment. I think you would have learned about carbon cycle, okay, or the water cycle, for instance, in school, right? So what is the water cycle? So water gets evaporated and then it gets condensed, it forms clouds, gets condensed and then comes back to the earth's surface, right, in the form of rain. But and the total amount of water on the earth remains constant, so it's not going to change. However, we still say that there is water scarcity. Why do we do that? So that comes after this. So the advent of industrialization, okay. So because of this, what we have done is we have adopted a linear approach. That means take the resources, you make whatever you want, you use it and then dispose it, okay, that's it. So if you do that then obviously the nutrients or the resources are not getting back to the environment, right? They are ending up in a landfill somewhere, okay. So this applies for water as well, because there are lots of industries, all industries use water, okay. But are they doing anything to replenish the water resources, that the fresh water resources that they are using? That is the question. So if they are doing that, then that comes under a triple bottom line approach, which we saw in the first lecture. So triple bottom line, that is they care about the environment as well and the social sustainability, okay. But currently the industries or the economy that we have currently is a linear economy, that is take, make, dispose model, okay. And so in this model, the end of life of a product is not taken care of, okay. So the cyclic flow, like I was just telling you about the water cycle and all, so that is not taken care of, that does not happen. So this approach is highly unsustainable. So why is it unsustainable? Because our planet is finite, okay. We do not have an infinite planet, right? Resources are not infinite. All resources have to end at some point, okay. So if you use the resources indiscriminately, what will happen? The resources will end sometime, okay. And that is why the Brundtland Commission, again you go back to the first lecture, the very definition of sustainable development is that we have to ensure enough resources are there for our future generations, okay. And circular economy is one way to do that, all right. So the broad definition of the circular economy, so circular economy is an economic system that replaces the end of life concept by reducing, reusing, recycling and recovering materials in the production, distribution and consumption processes. So I hope you understand this statement. So in a linear economy, what happens? We take it, we make it, we dispose it, okay. So that is the end of life, right? The disposing part of it, okay. So instead of disposing, what we need to do is we need to reduce maybe the materials used or maybe the energy. So basically increase the efficiency. We have to reuse, okay. So let's say you have an appliance, let's say you have a mobile phone, take for instance. If after 2 months after you buy the mobile phone, if there is some problem, will you throw it away or will you get it repaired, right? So the obvious answer is it's good for us also. So we can't throw it away and buy a new mobile phone because it's expensive. Okay, but why do we do that for less expensive materials? Let's say you have a pen, okay, and the refill is over. You need to buy a new refill, not a new pen. Okay, but because the pen is inexpensive, what we do is we throw out the pen and we buy a new pen. So we have to follow the same thing that we do for a mobile phone for the pen also. Okay, because just because this is inexpensive, we cannot treat it differently. So that's the whole concept of a circular economy. Or any appliance you have, so you have to repair it and reuse it. Okay, and if it is not repairable, for instance, then you can dispose it, but recycle any components that are recyclable in that. Okay, and recover materials from that. Let's say take mobile phone again. So the semiconductors or the circuits that can be reused, that can be recovered, should be recovered, and then they have to be remanufactured or reused. Okay, so this circular economy, it operates at a micro level, like for products, companies or consumers, at meso level, eco-industrial parks, and macro level in terms of city, region, nation, and so on. Okay, and it tries to accomplish sustainable development and creating environmental quality, economic prosperity, and social equity to benefit current and future generations. So this is the very definition of sustainable development itself. Okay, so how did circular economy evolve, right? So there are two different cycles. I'll come to this in a moment. So circular economy is a new model of economy which works in contrast with linear economy approach and tries to mitigate the damage. Okay, and then the most basic implication of the circular economy is to avoid the disposal of products and try to bring them back into the technical or biological cycle, and it emphasizes reuse, recycling, and remanufacturing. So let's go through this biological and technical cycle. So you have biological nutrients. Okay, nutrients as in you have nitrogen, and nitrogen you use, let's say, fertilizers or something, right? Urea and all that, or phosphorus fertilizers and so on. That is utilized by plants. Okay, and the plants can be converted into let's say if you're doing agriculture, it can be converted into some crops, right? So you produce those crops, or let's say you're using the crops to produce biofuels. So our product is either food, or let's say biofuels, or something else. Okay, and you use that, if we consider, let's say, biofuels, you use the biofuels. Okay, and then it is degraded in the end. Let's say if you the product is food, so you consume that food, and then there is some waste. Okay, the kitchen waste, garden waste, all of these, your vegetable and fruit peels and all that, that is biodegraded, compost is formed, and then nutrients are formed again. So this is a cycle happens in nature even if we don't do anything. Okay, but right now, as we have seen in the last lecture, the biodegradation part does not happen very efficiently these days, because we are mixing it with plastics and papers, and then we are dumping it somewhere, so that does not happen very effectively. So in the technical cycle, technical nutrients, so what does this mean? So the resources, like you have metals or some plastics or something with which you produce, all right, and 1 second, yeah, you produce some product. Okay, and then you use that product, and then instead of disposing the product, what you need to do is you have to return it and you have to recycle whatever components, or you have to recover some materials and so on, and then use it again in the cycle to produce the same product again, like remanufacturing or recovering materials and so on. Okay, for instance, if you have an IC engine, like your vehicle engine, right? So after like 15 years it's not functioning properly, a lot of materials can be recovered, or this IC engine can be remanufactured, okay, using the same materials. Okay, you can just take it out and then give it to a manufacturer. They can remanufacture this engine, okay, using most of the materials that made up the original engine. Okay, so you have these two cycles, the biological and technical cycle. So the depth of the idea. So what is circular economy? It's not just about bringing end of life product back into the system just once. So you cannot say that, okay, I'll just give you an example again. Let's say that you are bringing some okay, what example can I give you? Again, okay, consider municipal solid waste, and you're disposing some gadgets, okay, and you're taking some part, like let's say in that part there is some metal. So only that metal is recovered, and then that is recycled. That metal is recycled and then used somewhere, and the entire product is discarded. Most of the product is discarded. Okay, so that is not circular economy. Okay, that is what is existing right now. So you dispose something, and only that part which gives the maximum profit is being recycled, right? So that's not exactly circular economy. So we have to sustain that cycle in the long term. So we have to use as many parts in that gadget as possible to remanufacture it or reuse it, okay, or recycle it, okay. So we have to make some changes at the design and manufacturing level, okay. So if the if the cycle, the product cycle is very fast, okay, what happens? Let's say the lifetime of the product is very short. If you buy some product, it should last you for a long time, okay. That is the whole essence of this. So if you buy a product that lasts you only, let's say, 1 month, okay, and a lot of people are buying it, then you're going to end up with a lot of waste, okay. So you are going to dispose it at the end of its lifetime. So we may not have the capability to recycle that product or remanufacture that product again, okay, because of the sheer scale of it, okay. So that is the whole essence of this, right? Because if you have a longer lifetime of the product, then obviously it is going to be last you longer, right? And our recycling capabilities will be higher. Okay, then we also have to think about designing durable products and ensuring efficient processes for manufacturing and distribution in the overall system, okay. And so this approach, the circular economy, ultimately leads to sustainability. So the R's, I've been mentioning this in each slide actually. So refuse, that is, if you don't need something, don't use it, okay. Rethink, again, it's, do you need something, you have to rethink that, you have to think again, okay. Reduce the resource usage. Reuse, okay. So reuse is when reuse and repair, let's say. So repair is when you have a gadget and that gadget is not functioning properly. You should not just dispose it and get a new one. You should repair it and then use it again for as long as possible, okay. And you have to do that for all materials that you use, not just for the expensive materials. We do that for expensive materials already, because obviously it's going to cost us a lot to buy a new material, okay. I'll give you another example for this repair. So if you have clothes that are torn or something, earlier what we used to do is we used to stitch them together, or we used to take them to the tailor, okay, to stitch the clothes, and then we'll wear them again. But today we are just like, okay, we have enough resources, we have enough money now, so we could just dispose it and buy a new a shirt or something, right? So what we used to do when we had lesser money, we should actually continue doing that, because that is the sustainable approach. Okay. And refurbish, again this is for gadgets: refurbish, remanufacture, redesign, repurpose, okay, and recycle, of course, recover some materials that are usable, and resilient and regulate. So these are the R's of circular economy. So now let's talk about systems thinking approach. Okay, so what is systems thinking approach? So now let's assume that you okay, let's assume that your house is a system. Okay, you're analyzing something about your house, and in your house you have electricity, you have water, you have all these utilities, you have let's say furniture and everything. All right. Now if there is a problem in one of these utilities or your furniture, let's say you have a table that is that is not exactly standing on its four legs and it's wobbling or something, what will you do? You cannot do let's say if you're good at carpentry, then you can repair it yourself, okay, but if you're not, you need to bring a carpenter from outside, okay. So you cannot do anything from within the house that can repair your table. And similarly, if let's say there is a power cut in your home, can you power your home through something with, like, do you have a power plant within your home? You could have a diesel generator, that is another thing, but that cannot be for a long term, right? So you need to call your electricity board and then ask them what's going on. So that is the basic idea of the systems thinking approach. That is, you cannot think of only the system that you are analyzing. You have to think outside that also, outside the box, and then you have to consider the entire system as a whole, the extended system as a whole. So in this figure you see there is the system and subsystems, okay, and this is what we are, let's say, we are analyzing. But there are external systems and subsystems that are equally important, because these are affecting your system. So you need to think about this entire extended system. So there are some definitions. So it is based on the principle that understanding of the system content and context requires an appreciation of the properties of the whole system, like I just said, okay, the entire system, including interrelationships of parts and feedback processes, and how all this influence the whole system. Then there are a few more definitions. So it is a transdisciplinary, interdisciplinary, multidisciplinary approach. That's okay. So what does it aim, like, what is the goal? It aims at improving the understanding of the ways through which the performance of a system or an organization is related to its internal structure and external operating policies. All right. So the internal structures, that is internal systems, and external systems. So that's what, even it's the same definition, okay. So considering problems in its entirety, okay. So problem solving. So if you have a problem, you cannot simply think within your system, right? Like I just said, you have a power cut at your home, you have to call the electricity board. Maybe there is a transformer blast somewhere, okay. So you need to ask them to rectify that. So you need to think outside the box. So that is systems thinking approach. So you need to think about all the systems that are affecting your main system, okay. So the external systems, the external policies that are affecting your main system. So that is systems thinking approach. So we now come to the first case study. So a circular healthcare economy, okay. This study what they did is they carried out a cost savings assessment for refurbishing and recycling stainless steel instruments from hospitals. Okay, this was done for the Netherlands. So stainless steel instruments like you have that surgery, the knife used for surgery, or some stainless steel trays, they will have the mesh, stainless steel meshes and all they'll have, right? Like baskets, containers, discarded instruments, and used disposable instruments, all of these. So they did this analysis for 3 hospitals, and they collected around over 6 months. They did this over 6 months, and 1380 kgs of waste was collected. This is only stainless steel, so everything is like recyclable. Okay, so 17% of this was refurbished as in they just repaired it, made it like as good as new, and then sent it back to the hospitals. Okay, 79% of the waste was recycled. Okay, and 4% was disinfected and recycled. So disinfection is important because it is medical waste. Okay, so if it was used for some procedure, obviously you have to do some sterilization or disinfection. Okay, so the savings, what they calculated, around 38,000 euros. Okay, so just from the refurbished equipment, so instead of buying the new equipment, like you see here, disposable instruments, right? So if they had disposed these instruments and bought new, as compared to refurbishing it and then using that same equipment, they were able to save about 38,000 euros. Okay, so 1 euro is what I think close to 80 rupees today, I think. So you do the calculation. So if it is 40,000, then I think, yeah, around 32 lakhs over 6 months. Okay, so imagine the kind of savings, right? So this is for 3 hospitals. So 32, so 10 lakhs for 10 lakhs per hospital for 6 months. Okay, so that's a lot of money, right? Okay, and if you include the waste processing cost, that is, for hospitals it's not like homes, right? So for us, we just give the waste away to the municipal corporation, and then they don't charge us anything. So we pay taxes and all, so that is taken care of. But the hospitals, they need to pay some processing costs to dispose their waste. Why? Because it contains hazardous waste, so there should be some treatment and all that. So these municipalities, they charge something to the hospitals for disposing their waste. So instead of that, if they do this, right, the refurbishing and recycling and all, they can save some more money. So this is around 1,000 euros, not even that much, around 200-300 euros extra. But yeah, it's a good amount of money, right? Like I said, 10 lakhs for 6 months. That is the savings that they were able to get, right? And this is the model, right? So first you have the hospitals. So the hospitals, they disinfect these instruments or these waste that they are producing. Okay, they sterilize them, and then they send it to the instrument repair company. Okay, where this instrument repair company, what they do is they refurbish these instruments and then send it back to the hospitals where they can use it again. Okay, now what happens, whatever is not repairable or something, or any metal parts or something, okay, they sorted those recyclable metals and then sent it to the metal recycling company. Okay, so what the metal recycling company does is they melt these metals. Okay, they melt the stainless steel and then make metal sheets. Okay, and then they anneal it and they cool it down and make metal sheets. These metal sheets are sent back to the instrument repair company. So this repair company, right, they double down as manufacturing also. So they manufacture new equipment using these metal sheets. Okay, they manufacture new components for these equipment, and then send these recycled components back to the hospitals. So this is like a perfect cycle, right? Very little waste, or in fact in this case it is zero waste. Okay, because even when they are using these metal sheets, right? So for instance, if you have to cut the metal sheet, so you cannot use the metal sheets in its entirety. So you may have like one or two pieces of metal somewhere, right? Even that they are sending back to the recycling basket and then sorting it and sending it back here. So what happens is that also ends up being melted, and again this loop follows. So they're not leaving even one small piece of metal, they're not disposing it. So this is like a perfectly circular economy, right? The next is waste to energy biofuel optimization case study. Okay. So this study, what they did is they have done a multi-stage optimization of a bioethanol supply chain for California. Okay, so what are the feedstocks that they considered? Municipal solid waste, of course, that is paper waste, wood waste, and yard waste, and crop residues like corn stover, wheat straw, forest residues, rice straw, cotton residue, and so on. Okay, so they have optimized the cost of producing ethanol over the long term, incorporating biomass availability and demand constraints. That means that only so much you'll have some constraints on the availability of all these waste, so you cannot have infinite amount of waste also, right? So based on the availability of this and all these crop residues, how much biofuel is producible, okay, how much biofuel we can produce. They also consider the demand constraint, that is how much is the demand from the city, okay, or from the demand center essentially. Okay, and they have optimized feedstock portfolio. So which feedstock, how much we have to use, and then the biorefineries, that is the conversion plants from biomass to biofuel. How many biorefineries we need, what is the capacity of these biorefineries, and where should they be located. So you can check out this the study. They have given maps. I'm not including those maps here because yeah, that may lead to some infringement or something. So you can check out this study. Okay, they have included maps of California and where the biorefineries should be located and so on. And again, see, this study was not conducted in terms of circular economy, but we can consider it as a circular economy also, because they are using municipal solid waste from the cities, okay, and they are using crop residues from agriculture, both to produce biofuels, that is bioethanol, and then they are blending it, okay, blending and providing fuel to the cities again. All right. Now, how is the MSW produced in the first place? So agriculture produces food, and then you have the food waste, and there are lots of wastes that are generated that produces MSW, and that goes to the biorefinery for conversion to biofuels. So again, this is a circular economy. All right. So essentially, you are reducing the amount of waste that ends up in the landfill by using the municipal solid waste over here. And if you use crop residues in a lot of states in India, the farmers are burning these rice straw and wheat straws and all, right? The stubble burning, which is an issue in a lot of states. So that can be reduced. So because if you use that to produce bioethanol, so that creates value for the farmers also. So they can sell it and earn some more money. Okay. So this is a complete circular economy. So these are some of the results. So let's look at the cost breakup. So over the years they have done. So for 2010 and 2020, I've just taken for comparison the procurement cost, capital cost, that is investment cost, transportation of biomass and biofuel, and the production cost, that is the operation and maintenance cost and all that they have considered. So for 2020 it is slightly higher. If you can see, the procurement cost is slightly higher. Okay, the others, the capital cost is slightly lower in fact, and this can happen because of there is something called technology maturity. So if a technology is not very well known, okay, if it is a new technology that comes into the market, like remember the innovation chain again from the first lecture. So if a new technology has come into the market, then it has to stay on for a long time, and a lot of investment has to happen for the cost to come down. Okay, this happened even for solar photovoltaic. About 10 years back, 10-12 years back, when the solar program started in India, right, in 2010, the electricity tariff produced from solar power plants was around 17 rupees per unit of electricity. Today it is 2 rupees. Okay, so that is the difference. That is because of the technology maturity. The other two are almost similar, slightly higher for production cost. Now let's look at the ethanol production. This is in million gallons. Gallons is unit they use in the US. It's an imperial unit. Okay, gallons is around 4 liters. I think I have to check that. So million gallons per year. Okay, and what biomass you can use to produce. So let's see here, yard waste in 2010. According to the study, they are using only yard waste and paper waste, that is MSW only, to produce around 200 million gallons. Okay, but in 2020 they are producing 350 million gallons, and they have increased the contribution of MSW and also included wood waste, forest residues, cotton residues, corn stover, and wheat straw. And so all of this together, although the contribution is very low, okay, but yeah, so from 200 million gallons they've gone up to 350 million gallons. All right, so we are at the end of today's lecture. So if you have any questions, any doubts, I hope you understood what circular economy means and what it signifies and how it connects to the municipal solid waste management that we saw in the previous week, right? Anyone has any doubts? No? Okay, awesome. Let's go into the questions for today. Okay, first question: why is circular economy more sustainable than a linear economy? First, you have circular economy ensures efficient resource usage by avoiding extraction of new materials. B is reuse and repair of equipment reduces the need for new manufacturing, thereby saving on costs. Okay, sorry. So the example for this point you have seen in that hospital case study, right? When they have used refurbished stainless steel instruments, they are saving a lot on costs, right? Then C, you have circular economy principles lead to better health and sanitation due to lesser amount of waste reaching landfills, or D, all of the above. Do we have answers? Yes, absolutely, absolutely, yes. All of these are right because, yeah, efficient resource usage, because we are avoiding extraction of new materials. We are using the existing material, we are recycling the existing materials, and then it also saves on costs by reusing the or refurbishing or repairing the equipment, we are saving on cost. And better health and sanitation, because we are doing some kind of primary segregation, and then we are processing the waste in a more efficient way. So all of the above. Number 2, identify the cycle, that is technical cycle or biological cycle. I hope you remember that. So there are 2 cycles, technical cycle and biological cycle. So for the following circular economy measures, the first one is anaerobic digestion of garden waste. Second, remanufacturing of internal combustion engines at the end of its useful life. Third is repairing a broken mixer to prolong its life. Or 4, extracting and melting scrap metals from components. Okay, so the options are okay, but can you just tell me which one it is? Right, absolutely. Yeah, the first one is a biological cycle. Okay, because you are returning it to the biological nutrients, so to speak, to the environment. Remanufacturing is when you are bringing back the internal combustion engine into the loop again. Repairing a broken mixture, again you are prolonging its life. And extracting and melting scrap metals, this is again technical nutrient that you are bringing back to the cycle, right? Third, what is systems thinking perspective? Okay, A, assessment of associated extended systems to identify possible improvements in performance. So you're assessing some system, but you also need to look at the look outside the system if there are some issues with this system. Okay, that's what this means. Second is disposal of malfunctioning equipment and replacing it with newly manufactured equipment. Or C, assessment of environmental impacts of the system under scrutiny. Or D, all of the above. Yes, anyone else? Are you sure? You need me to go? Yeah, absolutely. Okay, so what is systems thinking perspective? So you have a system that you are scrutinizing, like I gave you the example of your own house. Okay, so over there you have some problem. Okay, so let's say yeah, like power cut. I gave you the example of power cut. You cannot solve this problem by sitting at home or by just doing nothing, right? You have to call someone from the electricity department, so that is outside your system, so that is an extended system. So you have to think about your entire extended system. So that is systems thinking perspective. Okay, so this is the answer, like assessment of associated extended systems to identify possible improvements in performance. Okay, question 4, identify true statements. A, circular economy approach is an end of pipeline solution. Okay, so what is end of pipeline solution? So you use everything, like you have a gadget, you use it up, and then finally at the end of it you're doing something about it, about the equipment, or about the MSW essentially, right? So that is an end of pipeline solution. Second, circular economy tries to minimize waste by prolonging useful life of technical equipment. Third, circular economy follows the philosophy of take, make, dispose. Or D, none of the above. Absolutely. Absolutely. That's right. That's right. It's not D because, see, this is right. Circular economy tries to minimize wastes, right, by prolonging useful life. And so you can either repair or refurbish, remanufacture, whatever you do and even at the end of its useful life, you are extracting components and then you're recycling those components. So that is and trying to minimize the waste. Okay, and take, make, dispose is linear economy, and it is not an end of pipeline solution. This is a whole process itself. So end of pipeline is at the end you want to dispose it. At that time you think, okay, what should I do with this? Okay, so there is a lot of MSW now. What do I do with it? So I can recycle, or I can compost, whatever it is at the end of it. So that's not an end of pipeline solution. It's a whole process, circular economy, right? Number 5. So recall from the last week the MSW management case study in Indore, right? So, which among the following measures taken by the Indore Municipal Corporation indicates a circular economy approach? So, A. Running city buses with biogas produced through anaerobic digestion of vegetable and fruit waste, or B. Bartan Bank. This I have not told you. Actually, what they have done is they have created something called a Bartan Bank. Bartan means vessels. So if you want some cutlery or some vessels for some function or something, you can go to this Bartan Bank and then you can take these vessels or these containers for rent. Okay, and even big restaurants are doing this. Okay, so instead of purchasing new vessels or new containers or new cutlery, you can go to these places and then rent, take these on rent and then return it to them. Okay. Next one is selling polythene briquettes. So this I think I covered last week. So they are separating polythene from plastics and all that, and using the polythene they're making pellets and briquettes and then selling that to irrigation pipe manufacturers. So or D, all of the above. Which one is it? Yes. B. Why is it B? We have different answers. Can someone justify the B's and the A's? Okay, I'll tell you. See, biogas. So they are using the vegetable and fruit waste and then making biogas and running the city buses with it. That is also a circular economy approach because they are minimizing these wastes, right? Bartan Bank, again, this is also a circular economy approach because you are reducing the amount of let's say containers need to be manufactured. So if let's say there is a marriage or something, the wedding party or something, okay, so if you are going to purchase so much cutlery, or if you are going to purchase normally what happens during wedding parties or some functions, we purchase plastic spoons and plastic plates or paper plates. So instead of that, if this Bartan Bank provides you with stainless steel containers, you're going to avoid plastics, right? You're going to avoid the paper plates. Okay, so that's again you're reducing the need for all these disposable plates. That is again reducing the waste. So polythene briquettes, again this is a straightforward thing because they are taking the MSW, they are separating out the plastics, the polythene, and then converting it into briquettes and giving it to irrigation pipe manufacturers, and they are manufacturing irrigation pipes using recycled plastic. So that is again a circular economy approach, right? I hope you got it, right? Okay, identify the circular economy approaches from the following. A. Exchanging old gadgets for new when it malfunctions the first time. Okay. B. Disposing old mobile phone in the garbage at the end of its useful life. C. Extracting working semiconductor circuits and discarding the rest of its parts. Or D. None of the above. I'll just read the options again. Exchanging old gadgets for new when it malfunctions the first time. So first time your mobile phone, let's say, after 1 month, it just malfunctions. There's some problem with your screen or something like that. Will you just go give it and get a new mobile, or will you get it repaired? Okay, that is what this means. Second is disposing old mobile phone in the garbage at the end of its useful life. Okay. C. Extracting working semiconductor circuits and discarding the rest of the parts. So at the end of the mobile phone's life, if there is some recycler, let's say they are recycling only the semiconductor circuits and discarding, let's say there's a lot of plastic in it, and all of this they are discarding. Okay, that's what this means. Or D. None of the above. Yes. Anyone else? Six. Yeah, absolutely. I'll tell you why this is the case. Why is it none of the above? Because you don't exchange at the first sign of trouble, right? You go and get it repaired. It will be under warranty. In fact, even if it is not under warranty, it makes sense for you to get it repaired instead of getting it replaced the first time. Maybe normally, if you buy a mobile phone or something, you will keep it for like let's say 3 or 4 years, right? That is the so even if it malfunctions during that time, you'll just get it repaired, right? And yeah, throwing the mobile phone in the garbage and then letting it stew there, that's again not a very good practice. This again, okay, they're very good that they're extracting the semiconductor circuits. What about the rest of the part? So this is also not a circular economy approach. Okay, not a good circular economy approach, that is. Okay. Number 7. Which of the following players help make circular economy a reality? Okay. A. Oil and gas companies. B. Cement and steel manufacturing companies. C. Cobblers, tailors and repair technicians. Or D. All of the above. Do we have answers? Are you sure? Again, are you sure? Okay, oil and gas companies, what are they doing? They are drilling somewhere or offshore or something. They're extracting oil and then, yeah, absolutely. So oil and gas companies, they are the exact opposite of what a sustainable economy should look like. Cement and steel manufacturing companies, most of them right now they are using cement and steel manufacturing companies, most of them what they are doing is they are using new steel or new resources, and they're polluting a lot. Okay, it causes a lot of carbon dioxide emissions. Whereas you have cobblers, right? You have cobblers. What do cobblers do? So you have your shoes. The shoes get torn or something. They repair it. Okay. Same thing with tailors, same thing with repair technicians. So you have your mixer grinder, let's say, or your TV or some other equipment in your house. So if it malfunctions, you're not going to just throw it away. You're going to call the technician. He's going to repair it for you. So what's the option here? There seems to be a lot of confusion over here. I've had only one right answer so far. Yes, absolutely. Right? I hope you understood, because see, like I said, oil and gas companies, they are not doing anything for circular economy. Same with cement and steel companies. Nothing for circular economy. Okay, but cobblers are doing it. Tailors are doing it. The repair technicians that you call, they are doing it. Okay, because they are prolonging the life of whatever product it is. Right? Okay. Right. This is a discussion. So have you seen examples of circular economy approaches around yourself? I've given you a lot of examples. Okay, so you can just tell from your own experience. So one more example I'll just tell you. So handing over your old clothes to the less fortunate. So you go to, so let's say, some orphanage or something, and then you give away your old clothes that you don't need anymore, or that don't fit you anymore, right? So what happens is, it's a noble cause, that is one thing, but it also keeps the materials in use for longer and reduces the amount of waste generated and reduces the need for new materials. Okay, so this is a circular economy approach. So can you see at least just one example? Any other example? Anyone? Just think about it, just a couple of minutes, and then you can whatever you've noticed around you. I can give you one more example, which, okay, you think about what your parents used to do. I think you'll get a lot of examples over there. Anyone? I'll give you one more example. So what my mother used to do, right? So you know these milk packets that we get, right? So Nandini or Raven or whatever it is. So after boiling the milk, or like after pouring the milk into the container, she used to wash it and then stick it on the walls to dry, and then she used to collect these wrappers, these packets, and sell it off to the recycler who comes, right? I think weekly once or something there will be someone who comes for old papers and all these milk covers and so on. All right. So now it seems like okay, we don't have to do that because we have enough money. All right. The thing is, it's such a great practice, it's very sustainable practice, that we should actually do that. So similar to that, can anyone give any example? Right, I just gave you two examples, right? One is donating your old clothes, second is selling your old papers and old milk covers to the recycler. Anything else? Let's just wait a couple of minutes. Yeah, bottles recycling, but I mean, have you seen it happening, or I'm saying from your own life, or maybe your parents or something like that. Okay, see, plastic bottles recycling, that is something to be done by the government. Okay, Okay, I can think of one more perfectly circular economy that um, you think about agriculture. Okay, yeah, I gave you that hint. Think about agriculture. Now, can someone tell me what happens in agriculture, or how that is that is a circular economy? Not right now. Agriculture as it happens now, as it happened maybe 200 years back, before tractors and before all these modern machines. Modern machines are very good. I mean, I'm not denying that, but before the modern machines came, or fertilizers, all of these came into the picture, agriculture or the rural economy, exactly, exactly. See, no, but the thing is, yeah, agricultural waste can be turned into manures. But what do we do with agricultural waste? Like rice straw, we give it to the animals, right? The ox or the cow. The ox or the cow, they eat this, and then they give like the animal waste, right? The cow dung and all. That is a great manure. Yeah, this is also good example. Coconut shells for craft work and all that. Yeah. So as I was saying, the animal waste like cow dung, which can be converted into manure again. So that goes back into agriculture, producing rice straw, and then you give it to the cows to eat. So that's a perfect circular economy, right? There are literally no wastes. Okay. So yeah, these are just some of the examples, and this is a very interesting topic. Actually, you can do some more reading on this if you are interested. Okay. So yeah, so that's all for today actually. So in case you have any other doubt or any question that you may want to ask me, you can ask. No more questions, no doubts. Okay, perfect. So I hope everything was understandable. Again, I'm repeating the same spiel, right? Okay, and thanks for joining. Okay, and I'll see you all next week. I think next week is the last. So now it's week 7, right? So week 8 is the last. So I'm thinking of multi-dimensional poverty index in the next um lesson, next session, because recently I think there were some rankings that were released by the government. So that's part of the sustainability development goals, and it's a very interesting topic. So I'll focus on that in the next week. Okay, and thank you so much. Okay, and have a great weekend. All right, see you. Bye.